the A subgroups. In specifics, we spoke about the A1 subgroup and the A2 subgroup. We discussed how we could identify and distinguish the A1 versus the A2. We had come to the conclusion that if we add anti-A1 lectin to known A cells, then if the result is positive or there's an agglutination, that individual would be A1. If the result is negative, then that individual would be A2. And if the person is AB and the same principle is applied to the A portion and the A portion indicates to be positive, then that person is A1B. And if the A portion is negative in the AB person, that individual is A2B. Right? So we have that all cleared in our mind, and we also established that there are more antigen binding sites on the A1, 810,000 to about 1,170,000 approximately, while on the A2 we have a lower number of antigen binding sites, about 240,000 to 290,000 on the red blood cell site. All right, so if we have that in mind, we can understand how the degree of reactivity will be when we add the various antisera. And the A1 and the A2 exist, but there are other subgroups that exist. We're going to try to touch a few of them so that we can have a better appreciation. But before we delve any further, I want to bring our attention to some structural characteristics of the A1 and the A2 RBC. So let us put that on the board. Structural characteristics. Alright, so the A2, let's start with the A2. The A2 red blood cell predominantly has A, and AB. Alright, so let's put that. Possesses A superscript A and A superscript B. All right, and this causes a situation where there is the unconversion of the H3 and the H4 antigen site. So unconverted, like when you have unconverted Christians, persons professing to be Christians, but they are not truly Christians in the way that their religion indicates that they should be. So these are unconverted. They should be expressing the H so that they can be A1, but they are not expressing, so they are A2. All right, now let's move now to the A1. So in the A1 red blood cell, we can identify, this is what is very important, we can identify the A superscript A, plus we can identify the A superscript B, plus we can identify the A superscript C, plus we can identify the A superscript D. So if you do the A, B, C, and D, right? And in this situation, we know that there are no unconverted H3 and H4 antigen site. And because there are no unconverted site, all of the sites are representing the A A1. All right, so that is just something that we need to understand. So that is a structural characteristic that I think would be necessary for us to appreciate a little bit more as we progress. Now, we have been speaking about the possibility of a A3, and yes, we have A3 available for us to investigate. And let us talk about it. The characteristics of the weak ABO phenotype. So let us put it up. Of weak ABO phenotype. And we're talking about the A type, right? Or let's call it a subgroup. So let us say, what phenotype are we looking at? So let's write the phenotype, and then we're going to try to see the reactivity that would exist between the anti-C or the anti-A, the anti-B, anti-AB, and the anti-H, right? And then we're going to see what is present in the serum of this individual. Now, the phenotype, then we're going to look at the reagents, reagent. So the phenotype, we want to start with A3. Then we're going to look at the anti-series, anti-A. Then we're going to have anti-B, anti-AB, and anti-H. So 1, 2, 3, 4. All right. So we can see what is happening. And then in the serum, so let us put a big double line right here and a big double line right here as we move over into the antibodies in the serum. All right, so we're going to think about having the anti-A, we're going to think about having the anti-B and the anti-A1. Let me see if we can get this a little bit better. Let me see if we can structure this a little bit better so that we don't have much confusion. So let me go into the pen. Let's bam, bam, and then we're gonna have bam, bam. All right, let's carry it across. Then for this, we're gonna have anti-A, anti-B, anti-AB, and anti-H. Then in the serum, we want to know if there's anti-A, we want to know if there's anti-B, and if there's anti-A1. All right? So, and then we're going to have the phenotype as usual. So now let us start with A3. So for the A3 person, there may be some form of mixed field reaction with the anti-A. So you may get a 2+ mixed field reaction. For the anti-B, there is no B present. For the AB, the same reaction you get in the A, you tend to get in the AB portion. And with the anti-H, remember with the A3 subgroup, this one has H present for all of it is not fully converted, right? So this here is going to give us a 3+ reaction. When we talk about in the serum, we're going to have no anti-A's, but we're going to have anti-B. With the A1, it may or may not react. So let us put plus or minus, so that is sometimes, all right? So sometimes it will react, other times it will not react. Now let us look at the AX, because we have an AX subtype or phenotype, and with this one you will get a weak reaction or no reaction taking place with the anti-A. When it comes on to the anti-B, you're going to have no reaction because it's an A individual, not a B individual. For the AB, you're going to have a 2+ reaction. But when it comes on to the H, there's going to be so much H there. You're going to have a 4+ reaction. So you're going to have a field day with the H's, right? In circulation, you may or may not have anti-A. And if it is present, it's going to be weak. For the anti-B, you probably have a little bit present, yes. And A1, there is a high possibility that you're going to have that present. All right. So this here, always you're going to have the A1 present. Then let us move to another one, A and E and D. All right. And this is not the one that is the end of the world, but this is very important as well. So for this one, we have a weak reaction in the anti-A, and we may have a mixed field, a weak mixed field reaction in the anti-A. For the anti-B, we're not going to expect anything because it's a patient that is A and not a patient that is B. And the same reaction we have in the anti-A, we expect that reaction to be in the AB. So the weak mixed field reaction. And this one, everything is not converted. So we're going to have a 4+ reaction. When it comes on to the serum, what is present in the serum, we're not going to have any anti-A in the serum, but we will have the anti-B in circulation. And when it comes on to reacting with the A1 lectin, we will sometimes have a reaction. So we're going to say plus or minus, right? Now, let us try another one. There is a special kind called AM. Yes, AM. So for this one, the anti-A, we have no reaction, or it's a weak reaction in the anti-A. When it comes on to the anti-B, we're not going to expect any reaction. So none of the A is supposed to react with the B, right? Because if it's just A, you're not going to react with the B any at all. All right? And for the anti-AB, we may have no reaction or a weak reaction, maybe a 1+ reaction. And for the anti-H, everything is not converted, so you're going to have a 4+ reaction taking place. When it comes on to the antibodies in the serum, we are not going to have any anti-A, but we are going to have anti-B. And guess what? It's not going to react with the A1 lectin. Then, after we move past that, we're going to have AY, yes, and we're not talking about the AY service that they have at church. We're talking about the A lowest subscript Y, all right? So for the anti-A, you're not going to have any reaction whatsoever. And this is something that I want you to bear in mind. And for the anti-B, there's no reaction. For the anti-AB, guess what? No reaction. But when it comes on to the anti-H, there's a 4+ reaction. Now, in circulation, we're not going to have any A antibodies in circulation, in the serum. But we're going to have the B in the serum. And there's going to be no reaction with the anti-A1. All right? Now, there is another A subgroup that I want us to bear in mind, and that is the AL, like Elohim, but it's not Elohim, it's A subscript EL, all right? So for the anti-A, anti-B, and anti-AB, there is no reaction. It's similar to the AY, the church situation. But when it comes on to the anti-H, there is a 4+ reaction. When we move now, this is where we get things a little bit tricky. When we move now into the antibodies, when it comes on to the anti-A being present, sometimes, so we're going to put plus or minus, we may have anti-A in the serum. So plus or minus. Anti-B, we are going to find the anti-B, and guess what? The A1, it is going to react with the A1. So positive, 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 positive reaction you're going to expect with the A1. All right? So these are just some characteristics of the weak ABO phenotype that I think that you should bear in mind so that you can have an appreciation for the whole design of the ABO blood group system. All right? What I want us to look at now is to see if we can determine if the substance is present in saliva of the secretor, or what substance is going to be present in those secretors or those with the secretor genes. All right, and to what degree is there a present, whether it is there's no present, there's a little trace, there is present, there is rarely present, or there's sometimes a present. So let us go into characteristics, same characteristics of the weak ABO phenotype. And we are talking about A's, right? A subgroup. Right, so let us make our table, phenotype. We're starting from scratch again. And then, if the person has a secretor gene, we want to know the substance that is present in the saliva. So substance present in the saliva. And we want to know the presence of the transferase in the serum. All right? So let us put presence of transferase in serum. All right, beautiful. So let us make our table and get ready to rumble. So we discussed the subgroup. So now in your mind, you should know the subgroup. We have A1, BAM. That is what majority of the population have. We have A2, BAM. We know that already. Then after that, we have some other subgroup. We have the A3, good. We have the AX. We have the AN. We have the AM. We have the AY. And then we have the AL. All right? So all of those are subgroups. And we just need to bear them in mind. So let us start with the A3. So the A3 subgroup, we are expecting the presence of A and H. A and H. All right? And we know that there's going to be H present because the anti-H reacted at 3 plus. Right? And we know that there's going to be A present because there was a mixed field reaction with the A. And not only that, it was a positive mixed field reaction. And transferase in the serum, we may have this sometimes. So this is not all the time, but sometimes we may have it. Now let us move into AX. And we're not talking about your X, we're talking about AX, the blood group, the subtype. All right? So substance that is present in the saliva, we are looking at the H. And the reason we are looking at the H is because anti-H was 4 plus, but for the anti-A, we realize that there is a weak or no reaction taking place. So majority of the time, you're going to have the H. So the presence of the transferase is going to be rarely. All right? Now for A end, E and D, and all of these are subscripts. For A end, we are going to have the H present. All right, the H is going to be present, and the transferase in the serum is not going to be there. So there's going to be no transferase in the serum. For the AM, we are going to have both the A and the H. The anti-B had a slight positivity. The H, anti-H, had a 4+ positivity. And yes, there is going to be transferase present. Now, for the AY, we are going to have the AH, and there's going to be trace amounts of transferase. And now the AL, Elohim, AL, we are going to just have the H present, and there's going to be no presence of a trace transferase in the serum. All right, so just bear those in mind as you go on your journey to explore the different classes of the A blood group, the ABO blood group system, and understand that these phenotypes do exist. So when we observe these phenotypes in our practice, there is a possibility that these will be implicated in a discrepancy, and these discrepancies have to be solved. Most times in solving these discrepancies, what has to be done is an enzymatic technique or an elution technique in order to determine the weaker subgroup and to distinguish them. All right, so serological techniques are usually used in order to distinguish and classify these subgroups. It is very important for us to just have an appreciation that even though we're accustomed to someone being a person can be A something else. It can be A, A1, A2, A3, AN, AX, AM, AY, AL. It all depends. All right, so I want us to have a mental picture as to a flow chart. So the cell reaction, so the red cell reaction with the anti-A and the anti-AB. So if there's a weakly agglutination taking place, the possibilities that we're looking at are A3, AX, AN, right? If there's no agglutination taking place, we are looking at absorption and elution of anti-A. So we're thinking about the possibility of AM, AY, and AL. All right, so let us try to put that on the board. So red blood cell reaction with anti-A and anti-AB. All right, so if we have a weak agglutination, weak agglutinates, we are thinking about possibly A3, we're thinking about AX, and we're thinking about AN. All right, good. And just peradventure, there is no agglutination. We have to examine a little further and do some absorption absorption and elution of the anti-A. All right. So when we think about this, we are thinking about the possibilities of AM. We're thinking about AY. And because we're already in church, let's just go to AL. All right. So this is just something that I want you to bear in mind. So now, if we get a mixed field reaction when we do this, so we get a mixed field reaction, we are thinking of A3. If 10% of the cells show very weak mixed field, we're thinking AX. All right. If we have weak agglutination with anti-AB only, we're thinking about AN. All right. So that there is just an idea for us to proceed with our investigation. So let us move into the non-agglutinations. All right. So when there is anti-A that is easily absorbed and eluted, and secretors demonstrate quantitatively in the saliva, we are thinking about AM. When the antibody absorption and elution occur, and the secretors contains a small amount of A in the saliva, we're thinking about AY. When the A absorption and elution occurs, and secretors contain only H substances and no A substances in the saliva, we're thinking about AL. All right, so bear that in mind. So for AM, let's put it down. AM, we do the anti-A elution. This is easy elution, EASY elution. All right, and we have secretion of A substance in the saliva. All right, now for the AY, we have anti-A eluded. All right, and then we have small amount, just small amount of A substances in the saliva. All right, and then the big boy, we have anti-A absorbed and eluted. So anti-A absorbed plus eluted, but this is the kicker, we have only, so let us write that big and bold, ONLY, H substances. We are thinking about an A that is L. All right, so we have only H substances and no A substance in saliva. All right, so just like that, we have covered majority of the A subgroups that we need to know. But we discussed that we have A subgroups and we also have B subgroups. So yes, we are going to have to go through the B subgroups. And when we talk about the B subgroups, I want you to think about having B3, just like how we have A3, we have BX, we have BM, we have BL, and we have the regular B, as the phenotype, the regular phenotype. So I just want you to digest this information. And in the next sitting, we're going to try to examine and explore the B subgroups. And then after we have done that, we're going to try to move our attention to just understanding in detail a little bit more about the Bombay phenotype. With that said, class is dismissed. Enjoy your day.